Greetings everyone. So in today's lecture we will learn some basics of computer network, and the flow will go like this. We will start with the definition of the computer network. So first we will discuss about the term computer and then network. Computer means we give some kind of input to the machine and it computes the data based on some algorithm and it produces a desired information. That is the work of the computer, and because we are computing something, so that's why it possesses this term compute. Now when we want to transfer data from one place or information from one place to another place, then we need a transmission medium or the network of the devices to transfer the data from one place to another place. So we use this term network. So both the term combinedly says computer network ki compute some data, and now with the help of the network transfer the data from one place to another place. So as per this slide you can read the definition of data communication. This is data communications are the exchange of data between two devices via some form of transmission medium such as wire cable. We can also use the wireless medium to transfer the data. Now before laying down the structure for our network, we need to remember some points, means the basic characteristics of the network for the effective communication of the data. So effective communication of the data depends on the four factors. First is delivery, second is accuracy, third is timeline, and fourth is jitter. So now we will explain all the terms one by one. So delivery means ki our data should be reached up to the correct destination. So as per the definition, you can read from the slide also, the system must deliver data to the correct destination. It means ki the address of the destination should be defined and data must be received by the intended device or user and only by that device or user. It can be done only by when we define a exact address. So in computer network we use IP addresses for the correct delivery. Now the second term is the accuracy. Accuracy means whatever we are transferring from one place to another place, it should be reached to the destination intact. Means there should not be any modification in the information. As we know that we are transferring data from one place to another place through some third medium like wired or wireless, and all these mediums may suffer from the different kind of noise, like the traffic on the road. It can alter your data, and if you are using wireless medium, then we have lightning or the fog or another kind of obstruction. They may alter your data. So second characteristic or fundamental thing we should remember before laying down the network is the accuracy. The data should not be altered. Third fundamental characteristic is the timeline. Means you must deliver your data within a defined time. So if we send the data means after the desired time, then it is of no use. You can take the example of the mark sheet of a student. If the result is not declared within time, then the result may be used by the student and may not be. So same thing happens in the computer network. Like we are seeing a video or listening a song. If the bits or the data will not be transferred within time, then the information will be altered and it cannot be used by anyone. So the data transmission should be real time, or you can say within time it should be delivered. And fourth thing is the jitter. Jitter is the term where it refers to the variation in the packet arrival time. It happens due to uneven delay in the audio or the video, because we are sending the data from one place to another place, and every packet of the information may use different route for its transmission. So one packet have a delay of 30 seconds, another packet have a delay of 40 seconds. So there may be a pause. So we should take care about it. And the one most common solution for this problem is that first store the packet at the destination, and when all the packets will be delivered or arrived at the destination, then you will make them or put them in sequence and then transfer to the destination. So it can happen, though it increases the overhead of the buffer space. So we use it means like in case of meeting, many persons are want to meet you, then first they will sit into the reception area and then the person will meet. So the reception area is the buffer kind of thing. Now we will see the components of the system. So these are the components of the computer network. First component is the sender, another component is the receiver, third component is the medium, fourth component is the message, and fifth component is the protocol. So sender and receiver both are clear, means source and destination must be there before transmitting anything. Now based on the kind of data or the accuracy of the delivery or the timeline, we choose the medium. Like we can put a direct connection from one place to another place, source to destination, and that direct connection can be wired connection. So wired connection provide you a guaranteed delivery, reliable delivery, and accurate delivery. Why it provides all the things? Because there will be no interruption, disruption in transmitting the data. Fourth thing is the message we need. The message we transfer, it is required for the communication. And the last is the protocols. Protocols, as per the definition, this is the set of rules. Set of rules means the data will be of this kind, whether it will be image or picture, whether data will be encrypted, means you change the data from one form to another form to protect it from the malicious person in between the network. So these are the set of protocol. Like when we send an application to someone, then the application must be signed. So it is a set of rule. It is a protocol. Your application must be signed by yourself. So these kind of rules we need in computer network. Now we will discuss about the data flow. Data flow are of three kind here: simplex, half duplex, full duplex. So as per the slide, you can see first is the simplex, means the transmission of the data is only in one side, means it is a one-way transmission. Data will go always from the mainframe to the monitor. Direction of data is always a single side. Another example is the keyboard. Keyboard is the example of simplex data flow, means you can give the input to the system, you cannot take the input back to the keyboard. Mouse is the simplex form, monitor of the screen is the simplex form, printer is output device and form a simplex, means it can print the data only, it cannot give the input to the system. Second is the half duplex, where data can be flowed in both the direction, but at a time only in one direction. You can take the example of this, like the walkie-talkie is the best example for this. Means when we want to communicate, then we make a set of rule. First we will speak. Yes, now the person destination can speak or the source can speak. Like in the army movies, we see over. Now you can tell, and finally to terminate the connection, they say over and out to disconnect the communication. So this is the thing. The benefit of this is that you do not need to lay down two wires for the transmission. You can use the same wire for for transferring the data from source to destination and then back destination to source. So it saves the cost, but the limitation is that you can transfer only in one direction. Now when you want to transfer data in both direction simultaneously, then it is known as the full duplex. These are the simply road networks where means like the highways data will move in both the direction on the same road. So this is the data flow. Now we will discuss about the network criteria. As till now we have learned that it is a network is a set of devices, and set of devices like means the computers, it can be printer, it can be monitors, all the things are the devices, and to connect all these devices we need links. Links can be wired or wireless. So we will discuss these terms later or in detail, key wired and wireless, as soon as we will proceed with our lecture series. So in this section we will discuss network criteria first, then the physical structure of the network, and category of network will come under this physical structure. So before laying down the structure of the network, we keep the network criteria in our mind. So our network should give a performance. It depends on the network elements, like whether you are using the wired network or wireless. So definitely in wired there is a constant propagation delay, means you know the length of the wire from source to destination and you can exactly predict the traveling time. While in case of wireless you cannot predict because there are another environmental issues, and because of that there can be a delay or loss of information. So if you want to make a more performing network, then use the wired network. Second term or criteria for a good network is the reliability. Reliability we measure in terms of the failure rate of the network. Failure rate like means you transfer the data from one place to another place 10 times in a day and it delivered correctly all the time, so your reliability is quite high. When it transfers the data 9 times, then reliability is less. 8 times, then reliability is more less. So if you want to increase the reliability, then use the good hardware as well as the good algorithm which ensures the reliability of the data. So further, reliability can be in terms of the uptime of the network, means your network suffers from failure but you are able to correct it or to identify the fault in less time. The definition is not exact because it depends on the structure कि आपने कैसा create किया. So reliability depends on this thing. Next is the security, like we encrypt our data before transmitting, so it provides a secure transmission, or first you need to log in to the network, so it provides extra security layer. So three things we must keep in mind before laying down the structure for the network. Now we will discuss about the physical structure. Physical structure is also known as the topology of the network. What kind of topology we use, or you can say the network architecture we use to form our computer network. So before designing the computer network, we must understand about the types of connection. So type of connection is the direct connection between source to destination. It is known as the point to point, where you connect source and destination directly. And when we use or share a network to connect multiple devices, then it is known as the multi-point connection. So second part is the mainframe to multiple devices we are connecting. It is a multi-point connection, and in real life we can resemble it with the help of the water pipeline, because we have a water source at the Nigam and we get a connection from the main pipeline to get the water. So these are the two types of connection. Now we will discuss about the network architectures, or we can say categories of topology. So generally we divide our network architecture into four types. First is mesh, second is star, third is bus, and fourth is ring. Now let us see all of them in detail one by one. So we will start with the mesh topology. So as per the slide you can see there is a direct connection between every two devices. So in mesh topology there is a direct connection between every two devices. This is known as the mesh topology, and it is based on the mathematical system complete graph, where we have n number of vertices and we connect each and every vertices and we find out the number of connections required. The formula for that is n into n minus 1 by 2, where n is the number of vertices. Same formula is applicable for this mesh topology. It means you want to lay down a structure based on the mesh topology and you have n number of devices. So how many wires you need? So I need n into n minus 1 by 2 cables for connection between every device. So if I have 5 system here, as per the slide I have 5 system, so I need 5 into 5 minus 1 divided by 2. It means total 10 cables I need. So what are the advantage of the mesh topology? Though it is simple for implementation, make a direct connection between each and every device, but for this you need, means if I have 5 system, then I need 5 connection jacks in every system, or 4 connection jacks in every system, n minus 1 number of connection jack in every system to connect the devices. So this is the main challenge. Second is the number of wires. We need more, so it again increase the cost. So first thing the jacks we need, second thing is the cable we need. So it in both the things increases the cost of the system. Though it is a reliable transmission because we have direct connection between each and every device, and if any time any direct connection face some kind of failure, then there is a alternate route. Means like from this station to this station we face a direct connection problem, then we can transfer the data either from this route or from this route. So this is the thing here. So mesh topology provides a reliable transmission, and another problem is that the fault identification is not easy here because there is a net of wires, so it is not easy to identify the faulty cable. So to ease or remove these kind of problem, we have next topology, that is the star topology. So star topology, the main attraction is that we have a central device that is known as the hub. We have multiple stations and each one is connected through this central hub. So there is a direct connection between every two station, but via hub only. So it is easy to implement because we need less number of cables. Means if I have n number of systems, then I need only n cables. So here as per the slide you have 4 devices, then you need only 4 wires. But the only problem is that if any time your hub is facing some issues, then your communication will be stopped at all. But again, it is easy to identify the fault, because if station 1 is facing some problem, then the light of this point of the hub will get switched off, and you will be easily knowing which station is facing problem. So fault identification is easy, replacement is again easy. If wire is faulty, then replace the wire. So you can say you can make the system or you can do the corrections within time, or in a very less time, you can say. So this is the advantage of the hub. Next system we have a bus topology. Bus topology is same as our water pipeline. We need a backbone cable from the source. This is the cable source, you can say, and this is the backbone cable. And whenever and wherever we need a connection, we just tap into the backbone cable. But this backbone cable has a limited capacity, so you can, if you add more number of systems into the cable, then you will face which kind of problem? You will not get the data in desired time. This is the problem. So if you scale your network, then you have to change the backbone cable. So to change the backbone cable is a costly affair. So we should avoid this kind of structure. Second problem is that fault identification is not easy. Like from the slide, if we see, if this particular system face some connection issue, then I have to check previous system, and again if this is also facing, then I have to check first system. Means if this system is not getting the data, then I have to check all the system existing before this. So this is the main problem. So you can say fault identification is not easy. Only benefit of this is that implementation is easy, and scalability means whenever you want to increase the size of the network, you just tap in one cable. So that thing is easy with this. Next topology we have is the ring topology. As per the diagram, you can see the stations are connected in form of a ring. So here is a backbone cable. The only difference is that they form a ring. Means you can transfer the data from one place to another place in a circular fashion. Scalability is again easy. You just insert a system in between anywhere, and it just needs 2 more number of cables and 2 more connectors. So it is the only requirement, and you can transfer the data from one place to another place. The only problem is that you have to decide the flow of the information, direction of the flow of the information, clockwise or anti-clockwise. And if sometimes the backbone cable face some issue, then you cannot transfer the data. Second problem is that with this topology especially, I can transfer the data only to the next system. Like in this case, as per the slide, if you want to transfer data from this station to this station, and I am using clockwise direction of the flow, then first I need to send the data to this system, and then this station will send the data to this station, and then this station will send the data to this station. So the main problem with this kind of transmission is the security, because the intermediary system can read your system and they can alter your information. So it is a threat, but it can be avoided with the help of encryption algorithm. So these are the things. Thank you for this lecture.